Hi, welcome back. So in this module, we're going to talk about how to write a good and faster JavaScript.
All right.
Okay, so this module is about writing fast JavaScript. Because really, if you look into the whole course, we talk about all the principles, strategies to help you optimize your program. But then fundamental thing is, how about your JavaScript code, right? Can you be a better JavaScript developer? This is something I think it's also very important. So let's look at what we want to cover here. We want to still talk about the importance of using JSON. And we want to actually still share with you the innerHTML, still working well. And then we're going to talk about numbers in JavaScript. Arrays, that's another thing to really talk about. And then the other interesting thing is about how to initialize JavaScript on demand. What is the traditional way of doing that? If we have any new ways of doing that. So JD is going to tell us a really good story on that. And then, last but not least, is we're going to talk about how to work efficiently with DOM object. Okay, so you could see there quite a bit of content there. So let's actually, go back and sort of run through it. So first thing, JSON. JSON is always faster than XML. So look at this example, right? So I know like a lot of people still like to use the XML representation. And then if you still work with the service-oriented architecture, SOAP message, all those things, it is based on XML, right? So, but nowadays, with all the modern browsers, with all the engines, JSON is really catching up a lot of momentum. Almost all the major libraries or the API always support JSON. And one thing good about a JSON is the JSON representation is very simple. And it's not a little tricky like XML, right? And the parsing of the JSON object and everything would be a lot faster. So if you have some old XML data, if you can, try to convert it into a JSON format, because performance-wise, JSON is always faster than XML. The other thing we want to share with you is for the XML data, a lot of times you have to come out with your own parsing way, right? You have to parsing from object to string, string to object. Well, with JSON, you have very easy to use built-in JSON methods. So for example, when you look at, I work with a particular JSON method, I want parsing that a particular string, I could call JSON parse, which is a native built-in method, right? And the same thing here, I want to actually, parsing this object into a string, I call stringify, right? So a lot of you already use that, so that's good. But if, in case you still work with XML data, then you could migrate it into JSON and take advantage of these two built-in JSON methods. Okay, next is innerHTML. Now, I know some of you say, is innerHTML still good? Yes, it's still good. All right, so it is really for you to use innerHTML to improve the DOM efficiency. So very simple example would be like what we have here. Get element by ID, user, and then you put in very simple string like a username. And then this way you could actually separate the dynamic content from a static. You could actually fit in very simple string instead of you to try to come out with a DOM object and work with them. That way, use a simple string, use innerHTML will be 10 to 15 times compared to work with DOM object. So this is actually something very simple, but it's still good to use.
It simplifies things a little bit because
right.
You can receive text from the server side and then just use that text to modify the content of your page without having to create the intermediate DOM objects by hand and populate them. You can just assign the HTML. There's other helpers for plain text like text content and inner text, but generally for blocks of HTML, innerHTML works great. There may be cases around the edge where creating them by hand is better, but generally speaking, innerHTML is efficient enough.
Mm-hmm. Correct. So old technique, but still good to use. Okay, so numbers. Okay, so I know JavaScript, a lot of people love it because it's so flexible. It's so easy to get into. And all the numbers in JavaScript is really, based on IEEE 64-bit floating point numbers. Super, super flexible, right? And then I just say, that's the data type I'm having. However, because of flexibility, you do have to sort of take the performance and optimization challenge. And let's actually deep dive into to see what's really going on here. Okay, so basically with all those numbers in JavaScript, and you actually work with, you roughly could actually separate them into two kind of data type. So one is, let's actually first talk about a stack and a heap, in case you never heard of that, right? In general, I'm not going to go into the detail, but stack is something with fixed length, and it's very fast to get access to. So if you can stay with a stack, work with stack, that will actually improve the performance.
It's memory.
It's memory, exactly. It's the way you work with memory. Either you put it on the stack or put it on heap, right? So, but for the long term, a lot of times, heap is with a variable length, but it has a slower access to it. So it is going to slow down your performance. So how are we going to actually address the number with different kind of memory allocation stack and heap? So what you can do is, if you look into the integer, right? So the 31-bit tagged integers, those are 31 bits. If it's 31-bit integer, you could actually safely to put it on the stack. And so everything, your area, your memory area to work with is stack, because stack is faster to get access to work with, so that overall, if we use 31 bits integer, it will be much faster. Whereas if you, for some reason, you have to use floating points, or the nature of your app, you have to use 32 bits integer or floats, basically it's all 32 bits, right? Then in that case, then you have to leave it into the heap. Okay, heap, like we said, it's actually a little slower to get access and to manipulate your data, to work with your data. So if it's a floating point, then we have to have it to put it on the heap. Okay, so 31 bits stack, 32 bits floating, or 32 bits integer on the heap. So stay with 31 bits integer as much as you can, right? And then if you have to work with floating, then you have to work with heap.
And you can really see this in like a game engine where you have a render loop and something that's being executed quite frequently. You'll be able to see the effect of this in the cost. There's also a small sidetrack of this is when you're dealing with canvas animations and you're dealing with integer values versus floating values. You can cause the floating can not only, besides all of this heap and stack stuff, can also cause like sub-pixel rendering, which is also another performance hit associated with floats versus integers. So something else to keep in mind. Usually, if you can avoid the floats and stick with integers, you're going to have a better performance.
Right, exactly. And we're going to show you some examples later on, to see how good it is. Okay, so let's actually look into the 31-bit integer for fast math. Okay, so if we have a particular program like this, right? We have a variable north equals to 1, which it is basically a 31-bit integer. So we could actually put it in the stack, right? And then we have another variable called east, which is east, which is basically a string, right? So string, it has to sort of go to a heap because it's 32 bits. Again, we have a floating point, 0.1, and then that particular floating point is actually has to move onto the heap because it's 32 bits, right? And again, we have a hex kind of data, right? So again, 32 bits for sure. So we move on to the heap. So only the integer 31 bits integer could stay on the stack. The rest of the data type, floating, string, or hex data, all has to work with a heap. So just keep in mind, heap is slower, stack is faster.
So even working with strings, you get a cost associated with it. So
it has to sort of migrate into the heap.
I know a lot of devs, when they're asking me about performance tips, they say, should I work with strings or should I work with numbers? You should work with integers, above strings. And even if you have strings, if you convert them to, like, say, their character codes, their integer character codes, you'll be better off dealing with massive amounts of that, too, when you're dealing with integers versus strings.
True, very true. So actually, go back to the, like JD just said, if you can use integers, try to avoid use a floating point. So this example would just tell you that. So modern engines or the modern JavaScript engines are pretty smart. So for example, if I work with a mass, it's called the -0 thing, or 0, that's actually an indication for modern JavaScript engine to say, if you see that with this type of mass, then most likely it's indicate I work with integer. So this is actually a good thing to use, even though you could say I started with something different like data, not integer. But if you use this mass operation, right, then more likely JavaScript engine will say, okay, this is good, it's integer. So I'm going to do all the optimization for the integer, leave it on the stack, so it will run quite a bit faster.
The engine knows for sure that it's going to get an integer. There's no guesswork that has to be done with this.
Very true. And then versus the other case is the engine will think, okay, in this case, I divide by 2. So it says, okay, so I'm going to work with a floating point because the engine doesn't know, this is going to be integer or floating. So in this case, they will say, oh, it's a floating point. Then I could not do optimization for the integer. I have to leave it on the heap and then work on it further. So in this case, it will be a little slower, even though you're doing the same kind of mass, but then one way is definitely better than the other. So try to use this mass operation, avoid using the floats if you can. The other thing we're looking into is the type specialization for doing the mass. And then if you look into this example, it's a very simple example. All it does is calculating the 2 points, calculating the distance between 2 points, right? We have P1 and P2, and then we do a little math, take the square root of that and computing the distance. Okay, so here I have different data for the P1 and the P2. So for point 1, it looks like it's all integer data. It's 10, 10, right? X, Y coordinates. And then for the point 2 is 20, 20, still integer. However, for the point 3 and the point 4, they are either floating or hex data, right? So now, if we're going to actually computing the distance between point 1, which in this case is integer, and the point 3, in this case is a floating points, then basically you mix 2 data type, integer and floating, into the same mass function, so that the compiler look at that, it has to say, there's a floating there. I have to actually push it 32 bits. We'll leave it on the heap to work on that. So we'll be a little slow.
And by type specialization, they mean that when the function gets hot and is executed a lot of times, when the engine goes to generate the highly optimized machine code for that, it can't take advantage of the assumption that it's always a consistent type. So it has to generate less performant or less optimized code to handle a variety of different types. Whereas if you stick with the type, which we'll show in a second, it can generate faster, more performant code.
Exactly, yeah. So it's really an engine kind of warm up and how smart it is. But then as developers, we have to make sure, take advantage of the smartness of the type specialization, the smartness of the engine. And we have to do the code to make it happen. So on the other side, we're showing something which is will work a little better. So we actually could just separate this particular, it's a very simple method, right? So we could actually say we have 2 different methods. One is called distance floating point. So really hint the JavaScript engine is going to work with the floating point. And the other one is called distance int. So, and it's basically say I'm going to work with integers. So that when you have the data type 0.1, 0.2, so make sure for the distance integer, you make sure you always putting the integer there, right? And for the floating point, you could have put a floating or hex kind of data there. So that way, actually, you could take fully advantage of type specialization. So the engine will know, this is an integer kind of operation. Let me actually do the most optimization. Let it stay on the stack to have a fast manipulation. Whereas this one is, has to work with floating point, then I will leave it on the heap to do furthermore work.
And going back all the way to the first module, whenever we said there's a balance between optimization and reusability, you'll notice that the optimized code here, we're actually duplicating the method, but for specific types. And so in this case, if this was a premature optimization, you'd be creating the duplication of functions and more complexity when not needed. But in here, when we're showing you this example, it's assumed that we've profiled it and found that this was actually the performance issue, and this is a way to solve that.
Right. This probably will say the readability, maintainability-wise would be a little clear because it shows very clearly I want to actually take advantage of type specialization. That's why I separated two methods, the method into two. Okay, so this is something, try to use a consistent argument type like here, right? So it is actually very important to do that because if you specify, say, this is a distance in and putting a floating point there, then it's just not going to work as an integer kind of manipulation. So you have to watch out. Want to make sure put an integer here. All right, so we talked quite a bit about the numbers, how we work with the numbers with JavaScript, and it's especially kind of important to work with in the JavaScript numbers because it's so flexible, right? And then always use 31-bit integer mass because it will work with stack, so it will be faster. And then avoid to use floating points if you don't have to, right? But if you have to, then just by all means use it wherever you have to. And then take advantage of type specialization so that your code will get the most optimized by the JavaScript engine. So this is about a number, and I hope when you go back, you want to use a number, pay close attention to how you actually work with your number in the JavaScript. Next, which is a related topic, we actually want to talk about the arrays. So let's take a look. This is basically array example for internal structure, and it says it's Chakra. Chakra is actually the name of the JavaScript engine running in IE.
It's what I'm the perf PM of, right?
Yes, JD is actually the PM. We're so fortunate to have JD here. He is from the Chakra team, and I'm hoping JD could tell us more insight about the Chakra engine. Okay, so let's actually look at this very first example, which is I'm showing a new array. Didn't really say how big is the array and what is the data type. But fundamentally, when you actually have this kind of array, like an MPD array structure, for most of the engine, not just Chakra, it will create a type called int array, just like an MPD kind of base structure. And then afterwards, you say, oh, I have my first element equal to 1, which is integer. So you fit into that array with integer 1. And then you see, my second piece is here, which is 2.3. It's a floating point. So for the floating point, I really have to change my type into a float array, right? So not just it will put the second floating point into this float array, but you also have to copy this one from a previous int array into this float array. Okay. So
this is all doing it behind the scenes.
Behind the scenes.
Not something that the dev is.
No, we don't have to worry about that. But the engine has to do all the work in order to make it right? So, so when you do this kind of assignment, first piece is integer, second piece is floating point, and let's take a look at the third piece, which is a string, right? So if you have a string, then the compiler, the engine will say, okay, it's a string. Then I have to create another type called a var array. Var array actually has a least optimization, but because you have a string, so I have to give you that array, right? And then you put in a string there, you copy 1, you copy 2.3 from the previous float array in order to finish your data representation. So really, this is not something as end developers we have to worry about, but just if you don't do the array assignment carefully, putting different data type or mixture of data type, the engine is going to say, okay, I'm sorry, you have all kind of data there. I have to actually choose one big array type which will fit all the things, which in this case is a var array, which is the least optimized array. So think about that. If you don't have to use all the, say, strings in the array, maybe you have a different way of implement that, right? So let's actually dig into that and talk about different things. So the other things you probably should really pay attention is the pre-allocated arrays. So let's take a look at example. Now, you do things like there are multiple ways you could define an array, right? So you could do things like a new array, put something totally empty. Or you could say, okay, this is a new array, right? On the other side, in the green area, I have 100 elements inside the array, right? And then I go through the loop and to do that. Now, this way will be much faster than the other way. Why? Because the engine will see that particular new array constructor creation, and it will say, oh, I need to allocate 100 elements for that particular array. So I know I'll do the allocation inside the engine with 100. And when you do all the manipulation, everything, it's not going to change in the size of the array. So I don't have to create increase the size, create another array, copy back and forth again, right? Whereas if you go through with the empty array just like that, and then the engine will say, oh, okay, I don't know how big it is. I don't want to waste too much space, right? So let me start with something really, really small, very default. I think every engine, the size is different, but maybe Chakra.
It's a little different.
It's a little different.
Size, but
right.
Generally speaking, if you pre-allocate your array length, you get the faster accessing array, or the faster array. Various engines do different back storages for your array. In this case, though, the general rule is if you can pre-allocate, if you know your length ahead of time, then go ahead and allocate that length and then assign your values to it.
Right. So go back to this example. What you see here is you see the first example. Why it's slow is we didn't tell the engine what to do, right? So the engine would guess, kind of like, okay, give you some initial size. Okay, plus one. Okay, putting one more allocate one more slot for it. And when you go through the 100 times, I don't know how many times it has to go through, but it's quite significant. It's going to increase every slot one by one, and then obviously you would imagine the performance is not going to be that great.
Anytime you can give the engine a hint about what you're doing. So before we gave the engine a hint about the type we're using. In this case, we're giving the engine a hint about the size of the array we're creating. Later on, we'll give the engine a hint about the type of values that are going to be stored in the array. So giving the engine hints is a way that it doesn't have to profile and figure this stuff out. It's for sure going to know the things that you need to be able to tell it, and so it can better optimize for it.
Exactly. So give some hints. In this case, the size of array. So next, what we want to do is actually give some hint for the data. Okay. So again, it may not be that fast because we're working with a mixed array. Mixed array meaning we actually putting different kind of data type into it. So as a result, if you see from a previous slide, because mixed array, the engine has to downgrade all the array type into the slowest one. It's called a var array, right? So you have to sort of work with that. But still, there's still a good chance you could make it slightly faster, right? So by doing a little hint, for example, you allocate an array for, in this case, is 100,000. That's quite a big array. And then you're going to actually putting them into a loop. And then you say, okay, the very first element is actually a string type. It's a hint, right? So the engine will know, oh, okay, so this array is kind of huge, and I know the data type. It's a variable array, var array. So engine get a sense, and then they will actually do all the things based on what your hint suggested, and then do the operation on the arrays and so on. So in this case, if you give a little hint on the data type, even though you use the slowest array, it will still be a little bit faster.
Right, because in this case, it was doing all of this. So for 100,000 elements or more, it was optimizing it as an int array behind the scenes. And then at the very end, you throw a string on it, and it goes, now it's got to be a var array. So if you were able to tell it up front before it had to do all of that other optimization, that it's a var array, then it can avoid all that unnecessary work and just give you the appropriate array, the backing array for it.
Sure. And then in the slow way, if we go back to the slide, and you will see actually the slow way is just like what we showed it before, right? 100,000 array, huge array, but we didn't really give any hint. So the engine doesn't know which particular array type it should assign. So we probably go through the first element, right? If it's an integer, then it do an integer array. If the second one is a floating point, then they say, oh, okay, it's a floating array. Then I'm going to copy that integer into a floating array, create all the unnecessary array type. and the third piece maybe it's another integer, and then you will sort of go back and forth until you say, okay, there's a piece of string, so I have to sort of downgrade it into a variable array, right, in order to accommodate all the data type. But then here, the engine end up with doing a lot of copy and then creating the new array type, doing the what we call conversion, unnecessary conversion, because all the conversion, all the copy is going to delay the performance quite a bit. It's going to impact the performance. So even though it's a very simple thing, just to give a little hint at the beginning to specify the nature data type of your array, it's going to help quite a bit. So this is actually a quite useful tip, for us to do to work with larger data.
So what if you could create an array of a given type?
That's even better. And this is something I think, boy, you can read my mind. I'm actually talking about in my next slide, okay? So again, if you look into this particular one, and exactly just like JD suggested, right? Because he is from the Chakra engine team, so he speaks for his engine. He thinks, what would be the best if you do something, we do something, developer do something, right? And to make sure we take a full advantage of the engine, the optimization, so that we could make our code even faster. So in that case, you will look at, we actually could separate the array by encoding the float 64 array, and then we could create one array just based on that, so that all the data which will be inserted into that will be kind of converted into a floating point to sort of assign to that particular array. And then you could also have an integer 32 arrays, right? And then all your data will be just integer, right? So that it will do automatic conversion, and because you know the data type ahead of time, it doesn't have to guess, right? It doesn't have to try different data type, and it doesn't have to do unnecessary conversion and a copy. So that way, it will be a lot faster. Even you may put a little bit of different data, even though like in this case it's the same, but because you already defining floating 64 array, the integer 32 array, even though the data elements is the same, you will actually get a very fast response based on the array type.
So behind the scenes, Chakra will detect that you're using a normal array like a typed array and give you similar optimizations. But again, it's having to profile and figure that stuff out. Whereas if you're starting off with a typed array, it knows for sure what the type is and can optimize for that from the start. So it goes again with anytime you can be explicit about the intent of your type, the engine will be able to take advantage of that sooner and optimize better for that type.
Right. Very true, very true. And then if you go back to the slide, obviously the not so nice kind of way to do that is just say, still just define a 100 elements array without really specify what's the data type, right? So, and in that case, everything could happen, right? Choose a right type of array, conversion, copy, and all the things is gonna repeat again and again. So it's gonna be slow. Okay, so this is something I think it's quite useful because I know we've been doing a lot of copy, paste, delete, and all those kind of operation. But what's going to happen if we try to delete a particular element from a large piece of array, right? So let's take a look at this example. There are multiple ways we could do the same thing, right? We talk about that. So in the left-hand side, on my left, we have an array with 1,000 elements. And basically, this is basically a board matrix we're going to work with. And then I want to operate some operation on the array. And what I choose to use is delete. So delete is such a bad way of deleting your elements because they could force the type change and then do all the optimization.
So delete is one of those functionalities that you use only if you have to. In this case, it's taking an array that was dense and creating a sparse array, which disqualifies it from certain optimizations. In other times, when you're using an object, it creates a different backing, so a different behind-the-scenes type of that object, which again slows down property access. So anytime you can avoid delete, you should. Alternative, if you're dealing with a plain object, you can use null or undefined to assign to the value.
0.
Anything but delete.
But delete.
Sparse arrays are also less efficient whenever you're having to deal with iteration or any other kind of method that works on them because it it has to do more checks on the array, because before it could assume that it's completely populated, it doesn't have to walk the prototype. Engines can optimize for that. Dense or sparse arrays don't have that assumption, and so there's less optimizations that can be applied to that array.
Sure. So if you look at the other approach, which is at the right-hand side, this is actually a preferred approach. If you want to delete the element, just simply, assign it to 0 or something, without already using the delete and forcing all the type change and all so on. So just do that, right? So just like JD said, try to use a delete. Maybe there is some kind of niche case they may need to use that, but most likely you could avoid using that.
Try to avoid it.
Right. I would say avoid it for most of the case, right? And then try to use 0 or null, to really do the same
For Chakra, whenever you use that on an object, it taints that object for the lifetime of that object. So really just avoid it. Like any scripting guide, this doesn't even apply to just Chakra. If you look at other engines like V8, they'll tell you too, don't use delete. So if you can, just avoid it. I mean, it's there, it is part of the language, but it's not one that you would necessarily need to take advantage of.
Sure. Okay, so the other one is about enumerate arrays. Okay, what's the efficient way for you to access an array, right? So let's actually talk about that. So what you look at here is you have multiple ways of doing that. For variable item in some array or for each, and then there's a very simple for loop. However, if you look at the way we're actually computing this a.length every time we go through a loop, so if you're going through, say, millions of time, you go through calculating that particular length millions of times, which really doesn't make any sense. So a better way of accessing those elements in an array will be actually cache that length. You just do it up in the front, call a.length, and use a for loop to finish the rest of the
So I can kind of talk to this a little bit more too. On the left-hand side, the first one is a for in loop over the array. Now this would only really show you an advantage if your array was sparse, which we had advised earlier. It's better to keep your array dense. Also, certain engines will treat that as a slow operation, because usually that means prototype walking, which is a slower operation. The next one that they have there is the ES5 for each method, and that's slower because nothing is going to be as fast as your bare bones for loop or while loop iteration. This has a function. It has an optional this binding. It may or may not be inlined by the engine. So there's lots of things that kind of slow that down. That last one though, about caching the length. That tip is eventually going to fade away because engines are getting smarter and are able to actually hoist that length and that check out. I know the newer version of Chakra will be able to do that too. So Windows 10 preview, you can try out the engine there. It automatically hoists that out. Other modern engines are doing the same thing. So eventually you may not have to worry about that. But just as we mentioned previously, anytime you can give the engine a hint.
For the older browsers, you probably have to watch out that.
Right, and anytime you can give the engine a hint about your intention, so in this case, by hoisting that out manually, you're saying, you don't have to worry, but the engine doesn't have to worry about it. I know I'm never going to mutate that array to modify its length, so we don't have to worry about it. And so anytime you can move the burden from the engine to being very explicit, it doesn't have to make assumptions and doesn't have to profile that. So you're going to get faster code regardless of whether the engine optimizes for it or not.
Right. Okay, so in review, we actually talk about a few best practices for using the array, right? So we talk about how to pre-allocate arrays, give the hint like JD talked about, keep the type of array consistent, right? Use the type of arrays whenever it's possible, right? Predefined with an integer array or floating array. Keep array dense, right? And enumerate array more efficiently. Okay, so we're going to actually quickly move on to the next chapter. I think JD has a story to share with us. How to initialize JavaScript on demand.
All right, so JavaScript on demand. We had hinted about this earlier, and this is basically deferring loading and executing of JavaScript until it's needed. So right now on the slide, it's basically the primitive form of doing this. This is before modules and module loaders. You would grab the head element, create a script element, set the source attribute, and append the script element to the document. And then at that point in time, it would load your code. But now you can take advantage of modular code module loaders. And so that's what I'll get into here. This is basically just going over the example. We've already done that, so I can go here. Module overview. Why modules? Modules are great because they allow you to break up something that is like a monolithic chunk of code into its smaller components. Usually, the general rule for modules is it should do one thing and do one thing well. And then other things can depend on it. And then you can have dependencies of modules that just do one thing and one thing well. It keeps your code simple, it reduces the complexity, and it allows you to include just the pieces of the code you need. So for example, if you have a modular library, you don't have to worry about including the entire thing. So say the entire thing weighs 500 kilobytes, but you're only using one or two methods. If it was modularized, then you could just include the pieces you need. There are various module formats. So for the web in the browser, there's AMD module format. Eventually, with the next iteration of JavaScript, there will be ES modules. So ES6, ES 2015, whatever the name happens to be at the time, will eventually have modules baked into the browser. So you'll eventually get that in the browser. But until then, there's other formats. And so the AMD modules for the browser, if you're server side, so if you're doing something in Node or Node.js, CommonJS, there is a module format for that. And then later on, I'll also cover just a brief overview of some of the build tools you can use to compile those modules when you're done, kind of like the optimization step where it compiles it and minifies it and removes dead code. So moving on, let's see. Here is the example of the AMD module format. The AMD, it stands for Asynchronous Module Definition, and it is extremely configurable. You'll notice this when you're moving to the server side, it may not be as configurable. With this, you can define paths, you can define aliases, you can define packages. It doesn't matter if something is an absolute path or a relative path, everything is configurable there. So even if the module has an identifier of A and your other module has an identifier of B, you can map A to B, which is really handy whenever you're wanting to swap pieces of code out. So in this slide here, I've got just a basic example of a module definition for an AMD module loader. You can see it requires the define call, an array of the modules you're wanting to load, so the identifier. In this case, I'm loading module A, and then asynchronously, so once that module then loads, at that point in time, it will call the callback and pass the whatever is exported from that module in as the A parameter, where you can then operate on that. So I think I have a demo for that, and so here it is. Okay, let's see. Demo time. So in this demo, it's going to be a very basic demo. Basically, when I refresh the page, it's going to load a module, and that module is going to export a string called example. So let's see what happens here. Okay, it says hello from example file. Pretty basic. Let's look at the actual code for that. Here we go. Here is the source code. Let me zoom in on that. All right. So we can zoom in here. We can see the module definition. Here I'm setting the paths. So before I mentioned AMD modules are extremely customizable. In this case, what I'm doing is setting the configuration and immediately requesting the module load. Other module loaders allow you to define the configuration up front and then at a later time load your module. So you can load it when you need. It doesn't have to be initially like all in one shot. This was just for the simplicity of the example. I'm setting the path for the example module as /example. You notice I'm not having to say .js. The module loader knows that I'm loading a JavaScript file, so I don't have to include the .js. And then because the example file happens to also have an ID of example based on the path name, I can say I want to load that example and then alert whatever the example is giving me. So if I look at the example file here, I think that text may already be big enough, but I'm going to zoom in anyways.
Cool.
The define here, this is inside the actual example.js that's being loaded. I call the define function, and since I'm not having to depend on any other module, I pass it an empty array. Normally, if this was Backbone, for example, it would say, hey, I depend on underscore and maybe also jQuery, and so it would have to load them up. In this case, I have no dependencies, so it's an empty array, and then I'm just returning empty example file, the string. Now that could be an object, that could be another function. It's really up to you what you return and export with AMD. In this case, as you saw before, I'm exporting the string and then it was able to alert that. But now I want to show kind of a more advanced example, and that's going to be loading jQuery. So in this example, I refresh and it says, hey, jQuery version 2.1.3 in the example. And let me zoom in on that too. There it is. That's the alert. So let's look at the source for that. And if I go here and I zoom in on that, you can see it looks very similar to the basic example. I'm saying, hey, the identifier is jQuery and the paths, and here is a location to the file. But you notice it's not a local file. It's pointing to the downloaded file from jQuery. Ideally, you would want that to be a CDN, maybe the Google CDN or CDN.js, anything that you would prefer.
And then in the crowd.
Right, yeah. And then it loads jQuery as you're saying, hey, I want to load the module called jQuery, and then jQuery has this built in, has AMD support built in to the library, so you don't have to do anything. You can just load jQuery up on demand, and the $sign will be there because I've named it the parameter, and then of course I have access to all of jQuery. So in this case, I'm just alerting its version number, but you could do, so much more with jQuery. So that's the example there. So right out of the box, many popular JavaScript libraries have AMD support built in, so you can load those on demand, which is very neat. Let's go back to the slideshow. So that was AMD, kind of a whirlwind tool there. AMD has so much more options there too. You can have fallbacks for if a file fails to load locally or from a CDN, you can then have an error back and handle failed resources and have alternate HTTP paths for resources. So if one fails, you can fall back to another one. There's all kinds of options there, so extremely configurable. But the other format is CommonJS or Node format. So a lot of times developers will conflate CommonJS and Node format. In this case, CommonJS is very similar to Node format, except for the export sugar, or the export syntax sugar around exporting a module. There's a thing called module.exports, which doesn't really exist in CommonJS. It's a Node extension. But generally, if a Node dev is mentioning CommonJS, they're referring to the Node style. And that's primarily server-side. It is a synchronous load. So before we were talking about async, this is a synchronous load. So it's going to load the file from your hard disk at that point of the require call. After that first load, it is then cached in an object in memory, so the next time you do request that, it just loads that from memory. It is less configurable by default. You can kind of hack around with the unpublished APIs, but then that's dealing with non-public APIs, which could be subject to change. I never like dealing with the pseudo-private APIs around the module loader. There are build optimizers available, so even though you're dealing with a server-side module format, you can compile it to work in the browser. They have something called Browserify, which is a build optimizer for Node modules that allows it to run in the browser, which handles the conversion and compilation for you. So you don't even have to worry about that. At the bottom, there is there's a tiny example of what loading a module in the CommonJS/Node.js format looks like. You have a require call and then a path to your module. If this was a package, you would just put the package identifier there. So if this was, for example, loading Lodash, you would just say require Lodash, and if that's a local package, it would just load that up for you. And then at that point, you can then use whatever is exported to A in this case. So that is modules. Let's see, the ES module format. So this is the one that is coming soon to browsers. By soon, I mean in the future, some point soon. It's in the next version of JavaScript or ECMAScript, which is what JavaScript is based off of. And this is kind of the example syntax here. Import A from your path. So slightly different syntax, but still doing the same thing, still loading script on demand. At the moment, so even though it's not in browsers, there is transpilers available for you. So basically tools that will convert your ES6 module code and transpile it to ES ES5, ES3 code. So it will work in modern browsers and older browsers for you. And that's just a build step. So similar before where we mentioned there were CSS preprocessors, there is JavaScript transpilers that will convert it from one format to another. So some of the build tools for that. There is something called Webpack, which allows you to work with AMD modules, Node modules, various module formats that can build, minify, optimize, and remove unused portions of your code for you automatically. There's a tool called Browserify, which works for Node modules to convert them to the web or for the browser, and then it also simulates some of the Node APIs for you too. So it really does seem like a very nice way to convert your code. For ES6, there's 6 to 5. That's actually been renamed to Babel, so we'll update our slide for that. ES6 module transpilers are moving at a very fast pace, so there's lots of churn and there's lots of updating. And then there's another one called Esperanto.js too. So if in doubt, just look at some of the slides here and we'll be able to give you updated information about the build tools there. Cool. Working with the DOM.
Okay. Okay, so DOM object is very important, right, in any of the parsing and object creation. So actually, let's talk about that. So if you look into some of the, coding we did, actually, this could be from my old code. And what I'm saying here is it's actually inside a loop, right? And what I'm doing is I'm actually calling 1, 2, 3, at least 3 DOM object. And then every time I call like a document, I access document object, DOM object, and go back to scripting, and then call get item by ID, another DOM object, get a result, and then I'm calling cross list, another DOM, and then go back to scripting engine. So I'm doing all the multiple back and forth with a DOM object and a scripting. So, and then if it's just running it once, maybe not bad, right? So, but what if, you're looking at this particular one is running in a loop, maybe running 10 billions of times, right? Then it's going to cost you quite a bit of resource because every time you do that, it's going to create unnecessary intermediate object for you, right? And not to mention the time to go back to JavaScript and DOM is going to take quite a bit of time to do that. So a better way of doing that here is, you could actually cache the data into an element. Just do it once at the beginning, and then using the cached element and do further operation inside the loop. This would be, I would call, $1 million tip. This is not really a brand new tip. It has been there for a while, but still, if you go back to your code, look at your coding, you will find you probably do something like that in your code. And by fix that, your JavaScript code will be quite a bit faster. So that's the first tip I want to share with you. The other tip to share with you is the automatic conversion of the DOM object. So, for example, we have this particular border size, and we know if we call a document get item by ID for a particular benchmark box, the value is always going to be a string, right? So, and in this particular case, I'm actually leaving it into a loop, maybe running again, 10 millions of times, and every time it's going to convert that piece of string into the border size, in this case, say 25, right? So every time, and it could be both dimension X and Y, and you could be running it just multiple times, right? Multiply this X, Y. So really, you're doing multiple conversions by something which is never changed, right? So what would be a better way of doing that is you parsing that into a parse in, just call a method called parse in, and then taking that array, say in this case it's 25, parsing into a border size, which is an integer 25, and then use this in the loop, right? So as a result, this is quite a bit slower. And if we actually just converting into an integer right at the beginning, it could actually save you 25% of marshalling time. 25% reduction is really significant. And then it's really something you should consider. And just by doing something called a parse in, doing some simple conversion really easily at the beginning, you could easily get a job done a lot faster.
I can tackle the next section.
Sure.
I'm going to skip ahead just a little bit in the interest of time and mention that we would be optimizing, you can use the DOM methods more efficiently. And so that means there is API available for you to avoid walking the DOM extraneously. So you can avoid things like text nodes and only get your elements that you're looking for. But I'll leave that as some homework for you. Just basically do a search for first element, child, next element, sibling, and the rest of the API listed here for you. And that would be a way to walk the DOM and traverse the DOM more efficiently. Another way is to not only use DOM more efficiently, but also use the query selectors more efficiently. So in this example, we are grabbing all of the elements with a style, with a class name of required, iterating over them and looking for the ones that are empty and saying, hey, you didn't pass validation. But you can do that more efficiently by leveraging the CSS3 pseudo selector of invalid. So now with CSS3 and HTML5, you have validation APIs built into the browser. So you don't have to have a JavaScript code or library to sit there and validate your form fields. You can just put the required attribute on your input, and then if it fails to have it properly filled in, so it's an empty input field, it will show up in the pseudo selector of input invalid. And so in this case, our validation code, we were able to remove several lines of code here and several iterations of DOM elements and just get the elements that failed validation, so the invalid input elements. And in this case, since our validation is we want no invalid elements, if there is no invalid elements, then it does pass validation. So CSS3 input validations, there's invalid, valid, required. I would recommend looking into some of those. They can reduce your scripts that you need on your page. They can do things like email validation for you built into the browser. I mean, that's really, really, really handy.
Right.
And so the next one is?
Right. So we probably don't really have time to, but okay. So there's another one, which is if we look at the DOM, the whole tree, right? And it is always a principle to follow, always maintain a small and healthy DOM. Because a lot of times people ask me, what would be a good size of DOM we should work with? I would say definitely less than 1,000, right? I mean, that's actually pretty big, 1,000 pretty big, and then more than that, it's going to be very expensive, takes a while, because working with DOM objects is never really trivial, never really so light, right? So you should always think about if you need to have all the DOM element in your code. So we probably don't have the time to really show this demo, but what we want to show you is choose your favorite website and then just go use F12 tool. In the console window, you could type the document query select all, and put a little wildcard there, and type $length, and actually it is the particular statement actually put it in the README on the GitHub, so you could actually copy and paste and follow. And you could take a look at your favorite website to see how many DOM objects you're creating. If you see it's definitely way above 1,000, that's probably it's a little too much. Take a look at your code to see if you fit into within 1,000 or less.
Right. Complex DOM hierarchies will complicate layout, will complicate formatting, will be slower to traverse with JavaScript. So if you can simplify that down, you'll create a more responsive application, a faster load time for your page, and an overall better experience. So if you can, always try to simplify that markup.
Right, absolutely. This is taking a little long for this one, but we did cover a lot of things: JSON, innerHTML, number, fast array, initialize, JavaScript module, how to efficient working with DOM, and hope we're providing some tips which is useful for your app. We're going to take a 10 minutes break, and as our last module, we're going to use a casual game as our case study to show you step by step how we could tune that application using all the things we will learn for the first 6 modules. See you in about 10 minutes.
Bye.